program to find the sum of following series. Sum equals to 1 square upon 1 factorial plus 3 square upon 3 factorial plus 5 square upon 5 factorial. Now, in this case, you need to generate an odd number, that is 1, 3, 5. So that we can generate using an I variable. So that is I variable should get incremented by 2. Second thing is, when I value is 1, you got to find out 1 factorial. When I value is 3, then you have to find out the 3 factorial. If factorial is having 1, okay, and if I value is second time if it is 3, then you can give here I 1 into, that is the previous factorial is present inside f into, that is I into I minus 1. So that is, it's going to take it as an I is 3 and I minus 1, it's going to be nothing but 2. So 3 into 2 is 6, 6 into 1 is nothing but 6. So you got the 3's factorial. Next time when I value has been incremented by 2, it's going to be our 5. The next we have to find out the 5 factorial. Already we are having 3 factorial. So 6 into 5 into 4. This will give you nothing but an 5 factorial. So that means to find out the ith factorial, here in this case you have to give f equals to f into I minus 1. And I value should get incremented by 2. So let's write the complete code. So here we have to read number of terms. This is term 1, term 2, term 3. Let's read the number of terms from the user. For that we'll take here n variable. And to generate this odd number, we'll take here I. And to store the factorial value, we'll store an variable, we'll take and declare a variable fact. And the sum is going to be of type float. Accept the value of n, enter value of n, or else you can call it as an enter number of terms. Enter number of terms. So we'll accept this number of terms in n by giving here scanf %d ampersand of n. Take a for loop, do the initialization. So I value has to start from 1. Okay, I value has to start from 1. And take one more variable x, which will keep track number of terms. Or else you can take I as a counter of number of terms, x as to generate here odd numbers 1, 3, 5. So I have not declared here x variable. Let's declare an x variable. So x will generate an odd number. So first it has to be an 1. And the initial factorial value, this 1 factorial is going to be nothing but an 1. So we can initialize that fact equals to 1. And sum should be initialized to 0. Okay. And this loop has to go for n number of terms. So give here I is less than or equal to n. And I will get incremented by 1. Now here, for the first term, everything is ready. That is, we wanted 1 factorial that is there inside this fact. So this x value should be first time 1, that is there, that's been initialized here. So, and also sum is been initialized to 0. So you can give a now sum equals to sum plus, it's going to be a 1 square, 3 square, so that 1, 3, 5 is been generated by x. So you have to find the square that you can get it through x into x divided by the factorial value. But we have to convert any 1 to an float. So we'll convert here factorial value to an float. Fine. So what happens now here is the sum value was 0. Sum value has been initialized to 0. And x has been initialized to first time 1. And the factorial value is also been initialized as in 1. So sum equals to sum plus, that is 0 plus 1 square. 1 into 1 is 1 square, divided by factorial is also 1.0. It's been converted to a float. The sum is going to be a 1. Okay. And then after that, the x value should get incremented by 2. So by giving here x equals to x plus 2. So x value will become now 3. And then I have to find out the 3's factorial. So already fact is having 1 factorial. So for that you have to calculate now the 3 factorial. So fact equals to previous fact value into x minus 1 into x. So what happens here? It's going to take it as an x value is now 3. So 1 into x minus 1 is going to be 3 minus 1 is 2 into x, that is going to be 3. So 3 2s are 6, 6 into 1 is 1, 6. So we got the 3's factorial. Then again go back here, I plus plus, I is going to be 2 and 2 is less than or equal to, if it is a number of terms is 3, comes down to this place, again sum equals to sum plus, it's going to tear x into x value is 3, so 3 into 3, 9 divided by the factorial, that is 6.0. So this is how it keeps on comparing. Next time again, x equals to x plus 2, it's going to be a 5. Fact equals to, I have to find out now 5 factorial. So it's going to be now 6 into x minus 1. That is going to be nothing but 5 minus 1 is going to be 4 into x. That is nothing but 5. So we'll find out the 5 factorial. Then again go back I plus plus. This keeps on doing it. When you come out of the loop, you have to display the sum. So you can give a printf sum of series is equals to percentage f, and then here return 0, then close this. This is a program to find the sum of series. So let's see the output in the code block. We have accepted the number of terms in an n, and in the for statement I have initialized sum equals to 0, factorial as 1, and I is going to keep track of number of terms, and x will generate an odd number, that is 135. So it's been initialized to 1, and condition is going to be I is less than or equal to n, and I plus plus, and here x equals to x plus 2, it's going to generate odd number, and then factorial equals to factorial into x minus 1, and within the loop sum equals to sum plus, it should be an here x square, x into x divided by float of factorial. Okay. And then once you come out of the loop, you can display the series. Fine. Let's compile this. So there's no error. Run it. It's asking for number of terms. I'll give number of terms as 3, and the output sum of series is 2.708. You can try out with some other value. I'll give number of terms as 5, 2.718. So this is the program to find the sum of series.